Hello learners, and welcome to the second installment of our video tutorials about horizontal projectiles. Now, in this video tutorial, we're going to be looking at types of problems where there aren't actual values assigned to anything. You'll be dealing only with variables, things that are known and given, and then the variables that you're going to try and solve. Now, our strategy is still going to be the same for solving these types of problems. We still separate our x dimension and work with it, and then we separate our y dimension and work with it. Because again, our ball or cannon or whatever has been fired is moving through both of these dimensions. Now, for the x dimension, as long as we make the assumption that our acceleration is 0, because again we're neglecting air resistance, then our equation is delta x equals vx t. Now, for the y dimension, we can really use all of the kinematics that we have at our disposal, but a key assumption for a horizontal projectile is our initial y velocity, v naught y, is going to be 0. Okay, so let's look at an example type problem, and let's see what types of things change as we change our variables. So let's say that we've got a ledge and we have a ball speeding off at some initial velocity, initial horizontal velocity, and we'll call that v naught. So it's leaving the table as a horizontal projectile. And let's say it's off the ground a certain height h. Now, let's also say that we have an acceleration that is just g. So g is my acceleration, and we can make this so that we could substitute in the gravity for Earth, we could substitute in the gravity for really any planet that we have. Now, this ball is going to roll and then leave, and then it's going to traverse a certain horizontal distance, delta x, where it lands. So this distance here is our delta x. Okay. Now, the kinematics that we have at our disposal: 1, delta x equals vxt. That is one, and really the only equation for our x dimension. So, let's say we're given a problem like this, and we're asked to solve for what is that delta x, but we can only do so in terms of variables that we have given to us. Well, problem there, we don't have time, because in order to solve for this delta x, we would need time. Now, we can get time by looking at the y dimension and looking at the variables we have and solving for that. So if this leaves as a horizontal projectile, write down everything that you know. You know v naught y is 0. Now, you know that your delta y is negative h. Now, why is it negative? Well, generally, you can make the ground y equals 0. And delta y is final minus initial. So I have negative h. And my gravity will be accelerating that object down. So my acceleration is negative g. So, let's look at the kinematics that we have at our disposal. We have v final equals v initial plus a t. And I need time in order to get delta x. Well, problem here, I don't know v final. The second equation, delta y equals v naught y t plus 1/2 a y t squared. That's very promising because v naught y is 0. I know delta y. I know a. There's only one unknown left, and that is time. So let's use this equation and let's solve for time. My delta y was negative h equals 1/2 of negative g t squared. My negatives cancel, and solving for t, I would get 2h over g, and then the square root of that would be time. Now I know time. I can take this and I can plug it in for t over here. So doing that, I get delta x being equal to Vx, which is v naught. The speed that I left is my x velocity. So v naught times the square root of 2h over g. That's how far my object goes. Now, look at what controls delta x. Not only how fast it leaves the table, but also the height and the gravity. Because your height and the gravity are affecting your fall time. The more fall time you have, the farther that ball will go. So think if you lowered gravity, you would increase delta x. Because think if you lowered gravity and you drop something, it will be in the air for a longer period of time. There's not as much pull from gravity. Look how they're inversely related. Here you have g on the bottom side, and here you have delta x on the top side, because it's delta x over 1. So if I increase gravity, my delta x would go down. These two are inversely related to each other. Look how delta x is related to v naught. They're directly related. If I doubled v naught, I would double delta x. Height is also directly related to delta x. If I increase it, it will go up, but not double and then double, because it's square root of 2h. So some interesting things at play here. If I alter v naught, I alter delta x. If I alter height, I alter delta x. If I alter g, I change delta x. All things governing how far my ball rolls off the table.